Hi, my name is Marvin Buliker, and this is second lab for machine vision. And today we're just going to be contrasting objects using the OpenMV and the algorithms that come inside of it. And we'll take a look at how we're able to achieve this. So this is just the setup that I use to mount the OpenMV and place it on top of the desk. That way I can be able to vary the light and look at all
Alright,
different
this is
things
the
that
setup.
affect how machine
Pretty
vision
much just
works.
attach the camera to the lamp so I can move the lights around, create varying brightness depending on the position, and then maximum exposure. So most of the project will be done on that condition, and then I'll just be writing code and uh, changing thresholds and values just to see what happens. Thank you.
So this time I'm using the binary filter to look at the image. It's good because you have two extreme thresholds and you can choose exactly what qualifies for this to be either true or false in the image,
Alright,
and
this
you
time
get
I'm just
back
looking at a
black and
box
white.
of
So it's really good
pens
at
and ink and
detecting
stuff, calligraphy
differences.
stuff,
Like if
and
you dial down your
I'm
process and
running
you just
a
want to see if
binary code.
something's off the range,
So
this will be able to detect that immediately.
I'll
So
link the code to the video, but as you can see, I'm just wrote a code here. I'm checking different threshold values, and then it'll take pictures, 4 images of each of the code, and then it'll run through, save that in the file. That way I can go through and see what changing the threshold does to the program. So I'm just going to run it real quick. Bear with me. Focus on the image, and go. So this is the first one. Captured that one. Changes the values. You can see the pen's a little better on that setting. And finally, it's the inverse of the other two. Okay, and I'll capture the image, and then we'll move on to using different scenarios. As you can see, some things are better off done with binary because you can find out the edges of stuff, especially when it's a mix of materials like that, and you want to identify one specifically out of all that. You can play around the threshold to just get specific items that you want.
so this time trying to find the perspective and orientation of objects, rotation, placement. What happens when you adjust stuff in the image? How does that affect the way
Hi, this time I got a
the
bunch
algorithm
of
is set up
rectangles.
and how it will be able to
So I
detect
got a
stuff
white background
that's
with a white
in
piece of
front of the
paper in the
camera.
middle. I got the brown one there, two dark items, and then yeah, I'm gonna run the code and see what happens. So with this one, we're just using April tags, just modified that, and we're gonna use that to find rectangles, and gonna run the program right now. Let's see how many. Alright, so as you can see, I'm finding 3, but I'm missing 1, and this one's always out of focus, so I can turn it around, and now we get a better view of the triangle. But at the same time, it's finding this edge to also be another count as a rectangle, just depending on where the way it's positioned. And then I can do a different view, it'll find that instead, and then the shadow also comes to play. So yeah, just like before, just make sure your thresholds and your area of interest is constrained. That way you can achieve repeatability.
And this time we're just going to try and see how the background color, the difference of color between objects, reflecting surfaces,
Alright, this
and
time I'm just gonna
heights and
use
shadows
fine
affects how
circles
the image is
just
detected.
to see how different types of circles are detected using the OpenMV. And as before, I will show you the code. I will have it in the description or in the comments somewhere. You can look at it. And so I'm just going to run the program because the serial will tell you how fast it's running and gives you the dimension of the circles it's able to identify. Because it has three for circles, you have your x, y, and the radius, and then you also have the magnitude of the circle. So those are the things that the logic is, the algorithm is going to be looking for in these circles. So I have six items here, and one of them is white, so it's almost the color of the background. Some of them are tall, some are short, and then we're just going to run it through and see what the camera can detect. So here we go. See, I'm able to get 5 out of all of them. This one's, because it's reflective, it's having issues. Uh, Sometimes the shadows, like if I manipulate this, sometimes you might get extra images just because of the way the shadow goes. So it's good practice to always try and get best light values when you're trying to run something, because the main goal of automation is repeatability and reproducibility. So see what works best for the code you've written and try to replicate it over and over.
All right, this time we're just going to try and use very light LED. Will change the brightness, will change the warmth and the coolness of the light being produced, and see how you can use equalization to make sure that all the images you end up capturing, once
Okay,
the
this time we're gonna
machine is
use
able to
a
see
square
it, will always
here, has
return
different
something
colors,
similar
so
because it
different
tries
light
to get
values.
to push all these
And then
RGB
I'm gonna
values
use
to
the
exactly
histogram
what threshold you set. That one
equalization. That way,
use the histogram equalization.
the OpenMV tries to find the optimum threshold every time the light values keep on changing. I'll try to keep it towards the middle as best as it can. It's a simple code. It's all when you just get into the snapshot, you choose to equalize the histogram. So I'm going to use a varying light LED over here, and then yeah, see what happens to the light values as we go up. Okay. Alright, there we go. So just see how the image changes when there's darkness, and then you keep on adding to it, and then the image will try to maintain there. Look at the histogram below the image. It'll try to always change the light value. It'll jump up and then it'll try and correct and go back to the middle, to the same level. So really powerful when you're trying to when you're working with environments that have varying lights. As you can see, we can both in the middle side, you can see the brightness keeps changing, and the hue too. We can make the color warm or cool, but the histogram equalizer will try and maintain the RGB values to something that's towards the medium. Alright, thank you.
Just that the binary values, edge detection is powerful because you can work with varying light differences. Because all you're looking for is where the edges are, and it's really good for really fast automated
Alright.
uh,
So this
processes
time we're
that
just
can
going to
be able to
use edge
identify
detection
errors by just
and the
looking at
code running.
comparing this
It's
to a
just
reference
using
point that you
Kenny
have
edge detector
given to the
to
machine.
see the edges of the objects the camera sees. So this one doesn't. The light value actually plays less of importance. Like you can see, you can move the features around. It just helps identify more stuff depending on the light angle, and so it just depends on how you manipulate the light and position the camera to see where the edges are. So some items might bleed in together, as you can see, based on how I'm moving the setup. It's actually pretty good resolution. You can actually read some of the words down there. Like the calculator, you can identify the buttons. And on the other side, the remote, but it just depends on which side the shadow is coming from. And then there's a piece of paper on top of the other block. You can see that, but it's bleeding into the item that's next to it. So yeah, it's pretty much edge detection. And you can use this. This one's pretty good if you have products that you want to identify quickly, because it runs pretty fast compared to and uses a higher frame rate than other features. So this is a powerful tool to use.
So this time, you're trying to find an image with varying colors, and you just want to identify one object out of the entire grid. So here I used multicolor blobs to find the one that fits the
Alright, this
parameters,
time
the
I
upper
just
limit and the
have the
lower
grid with
limit
the
that are
multiple
set for the
colors,
color. And
and I'm gonna
it
use
has to
the
be wide enough to
blob
qualify as
tracking,
the
colored
shape
blob
that
tracking
I'm
to
looking
just
for.
identify
So
the one that is
see
for the
how
threshold.
it went.
So take it to the screen, and you can see all the colors are there. It's trying to track all the colors, but it's put a nice circle on the one that's specifically set up for the threshold, the blue square to the right. So it's one way we can use to identify color segments from our image, which has various colors.
So that's how you can use different uh, codes to run the algorithm to help you identify stuff and objects using machine vision. Just depends on what you're looking for and how you want to get to the result you're looking for. You have to vary the light, you have to consider the color of the object, you want to consider the spacing of the objects, because sometimes detection can bleed into one another. So the more you dial down to exactly what values you need, the better outcome you'll get, and the more repeatability and reproducibility you will get, making it easier for you to automate whatever process you want. I do apologize for the sound quality today, because the AC had to be on. It was the hottest day in Seattle's history. So other than that, I just want to say thank you. Bye.